let's talk about how we're going to find equations of inverse functions. So we've got these step-by-steps listed out for us here. We're going to change f of x to a y. We're going to interchange the x and the y, so make the x and y switch places. Then we're going to solve for y and change the y back to an f inverse. So let me show you what this means right here on example 4. I've got this equation, f of x equals 2 minus 3x over 4, which, just so you know, can be written as this or that. I wrote it mostly like this so we can see that mx plus b form. Because right here, this first step, it wants us to graph this equation. So if I want to graph this in mx plus b, my y-intercept is 1/2. And then my slope is down 3 over 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And then I can go back the other direction. And there is my f of x equation. Now, step 2, it wants us to find the inverse equation. So what we're going to do is follow those steps. First off, we're going to change the f of x to a y. So I'm going to change that to a y. Then I'm going to interchange the x and the y. Then I'm going to solve for y. So if I want to solve for y, I'm going to minus 1/2 to both sides. And then I'm going to times both sides by -4/3. Because the negatives will cancel each other out. The 4's are on top and bottom. The 3's are on top and bottom. And now I've got a y by itself. So this -4/3 I'm going to distribute in. So I get -4/3 x. Plus, see that 4 times 1 is 4, 3 times 2 is 6, so that's 4/6, which simplifies to 2/3. Then, last step, I solve for y, change that y into an f inverse of x to show that this equation is the inverse of the one I started with. So that's how you solve for an inverse equation. Let's graph this one as well. So y-intercept is 2/3. And then I'm going to go down 4 over 3. 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And then I can go the other direction. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. So if I draw this, ta-da! So there's my equation, and my equation and its inverse, and the graph and its inverse. And if you think of that diagonal line, y equals x, you can see that if I take one and reflect it across, I get to the other, just like we said would happen before. So, now what we're going to do in this example is use what we know about inverses to find the range. Now, this is a really important problem we're talking about here, and here's why. We can find the domain by hand really easily. All we need to look at are denominators and even roots. However, finding the range by hand is a lot more complicated. It's way easier to find the range when looking at a graph. However, we said earlier that the range of f is the domain of G. So let me show you what this means here. I have g of x, and in a second, I'm going to find its inverse, g inverse of x. If I find the domain of this function, that will be the exact same as the range on this function. And vice versa. If I find the domain of g inverse, that would be the same thing as the range on g. So instead of trying to find the range by hand, I can just find the domain of the original and the inverse and switch them, and those are my ranges, which is a huge idea because range is such a difficult thing to find. So let's go through and do an example together. We're going to find the domain of g first. We don't have any even roots. We do have a denominator. So we say that denominator cannot equal 0. So that denominator cannot equal 1. So that means my domain is everything except 1, which means that is the range of this one. Because for inverses, the x's and the y's flip. That's why when I go to solve for this inverse, we talked about those steps just a little earlier, how we flip the x's and the y's, like I'm going to do here. The reason we do that is because for an inverse, the x's, the domain, and the y's, the range, flip places. That's why they flip. Now, when I go to solve for this inverse function, I'm going to do a couple really tricky things here that are really important because you're going to do these a lot, this process a lot in this class. So, first thing I'm going to do when solving this for y, I don't like denominators. So I'm going to do this so that I don't have anything in the denominator anymore. And I'm going to distribute that x. So now I've got this, no denominators. That's a good bonus. But I need to solve this for y. If you are ever stuck in solving for something, and you've got that something happening multiple times, so I've got a y here and a y there, you will always solve it the same way, which is anything that has that something, bring it all to the same side. So everything that has my y's, I bring to the same side. And the reason I do that is because now I can take a y out of both of those things. They have a y in common, so I can just take that y out. I'm actually going to move this up here so we have more room. Oops. So I took a y out that they have in common. And now that the y is taken out, I can divide, and my y is by itself. Ta-da! And now last step, I change that y into my inverse symbol. And there we go. There's my inverse function. So let's find the domain of this inverse function so then I can flip it over and have the range of the original. So I don't have any even roots. I do have a denominator. So that denominator cannot equal 0. So I know the domain is everything except negative 2. And since that's the domain of my inverse, I can come over here, and that becomes my range of the original. So this range, it can do any y value except negative 2. It will never ever equal negative 2. So, that is all we have in this video, talking about inverses. In the next video, we're going to come back to the square root of x and talk a little bit more about why it looks a little bit different than the x squared graph.